Hi, and welcome to another installment of Math Basics with Mr. Besh. Today what we're going to do is take a look at the washer and calculating its surface area. Now don't be intimidated by the shape. It's pretty basic and very systematic. There's a couple things you need to know about before you solve the surface area of a washer. First, you better have your formula sheet out and know how to calculate the surface area of a cylinder. 2 pi r squared plus 2 pi r h. Secondly, you need to know what a washer is. It's composed of 2 cylinders, a large one on the outside and a part cylinder in the inside. To calculate its surface area, it's a 3-part process. You're going to calculate the area of the large cylinder, you're going to subtract from it the circle on top and bottom of the smaller cylinder inside, and last but not least, you are going to add the lateral surface area of the cylinder in the inside. What you need to do is you need to, 2 key elements, 2 basic concepts. You need to know the heights of the cylinders and you need to know the radius of the cylinders. In my diagram, both of these cylinders have exactly the same height, 3 millimeters, but they're going to have different radiuses. The smaller cylinder contained within has a radius of 4 millimeters. The larger cylinder has a diameter of 18 millimeters. That means the radius is half of that, which is 9 millimeters. So these are very important numbers when we're calculating its surface area. Quickly, the formula for calculating the surface area of a cylinder is a 2-part process. The first part, 2 times pi times the radius, is basically your circle on top and your circle on the bottom. Once you calculate this, you want to jot this number aside. You are then going to add it to the second part, which is 2 times pi times the radius times the height. This is the lateral surface area. If you were to visualize for a second a Campbell's soup can, everybody knows this and everybody sees the red label on the outside. Well, the metal circle on top and the metal circle on the bottom would be the 2 pi r squared part, the top part. Whereas the Campbell's soup can, the red label, would be the 2 pi r h part. Now, we go back to our picture, we take a look at our key values, 3 being the height for both of my cylinders, 4 being my radius of my smaller cylinder, and 9 being my radius of my larger cylinder. And we want to complete our 3-step process. Step number 1, calculate the surface area of the large cylinder. Remember, step number 2, calculate the area of the smaller cylinder's circle on top and on the bottom and subtract that from the overall area of the large cylinder. And last but not least, we want to add to that the lateral surface area of the smaller cylinder, which is 2 pi r h. Remember, you could stick your finger inside the washer and feel a region that is inside the hole on the top and the bottom. That is an area that you must account for. So if I would walk you through this and show you all the steps using my data here, using the heights of both cylinders being 3 millimeters, the radius of the smaller cylinder being 4 millimeters, and the radius of the larger cylinder being 9 millimeters, this is what it looks like. The first step I do is calculate the surface area of the large cylinder. My formula is on top. So this is 2 times pi times 9 times 9 plus 2 times pi times 9 times 3. I get a grand total of 678.24. Now, the smaller cylinder contained within. The first thing I need to do is subtract from 678.24, my grand total. I need to subtract from that the first part of that surface area formula, the 2 pi r squared part, because what I'm doing is I'm getting rid of the circle on the top and the bottom that is not there. So 2 times pi times 4 gives me 100.48. So then I subtract that from 678.24 and get another total. The last step, the third step I need to do is I need to add to my total my 2 pi r h part. I need to add the lateral surface area of the smaller cylinder, which is 2 times pi times 4 times 3. This comes out to be 75.36. When I add these values, when I take 678.24 minus 100.48 and then plus 75.36, I get a grand total of 653.12 square millimeters. This is how you calculate the surface area of a washer. I hope you found this helpful and informative. Thanks.